Alright, so this is exercise 7J from the finance notes. Question 5. From the birth of little Jenny until her 16th birthday, Auntie Edna deposited $500 in an account that paid 7.5% compounding annually. At her 16th birthday, they stopped making deposits, and she lets it sit there for another 15 years. How much is in the account at the end of the 15 years? So, as always, let's start with a little diagram. So here we've got $500 going in when little Jenny is born, and then each year after that, another $500. And we do that little broken scale there until on her 16th birthday, there's the last $500. We then wait another 15 years, that'll take her through to 31, and that's when we find out how much it's got to be worth. So this first bit, well, you can do it without the calculator, or you can do it with TVM Solver. If you were doing it without the calculator, ignoring that $500 payment, we've got the future value of an annuity for 16 years, and you could go ahead and work that out. Here we've got the extra 500 at the start as well, so you'd have to use a future value on that. Just your future value, FV equals PV 1 plus I to the power of n. But let's just go ahead and put it all in on TVM Solver and see what we come up with. So we're into the compound interest. So this first bit is for 16 years. Compound interest at the end, it'll always be at the end for us, so we don't need to worry about changing that. 7.5% per annum. We start off by paying in $500, or was it Auntie Edna who paid in the 500, whoever it was? Yes, Auntie Edna pays in $500 and then continues to make a payment, so another negative 500. We're going to work out the future value, but before we do that, how many payments are happening per year? Just the one. So we're just compounding annually as well. So that's the information we need. You would write that down in the exam. So when you use TVM Solver, write down in the exam, you know, n equals, I equals, etc. And then we show that that is going to give me the value at that time under the 16. So we go ahead and do that, and the future value of that is 16,129.01761. 16,129.017, so that's 0.02. So $16,129.02, and then moving a lump sum forward, if you want to do it the old-fashioned way, FV equals PV 1 plus I to the n, or I over R to the n times R if we've got a different compounding period, but we don't need to worry about that. We can just go ahead and say, okay, we're doing this for 15 years. The percentage interest rate will stay the same. The present value, we're going to now just leave $16,129.02 in the account. Not going to make any more extra payments. Still happening once per year, so we solve for the future value. And there's our answer there. So the future value, 47.79. And that would be how much she'd have in the account at the end. If you want to be really pedantic, we could go back and make this 16,129. So going to let me edit that. 0.0. I can't really remember what it was. 0.1729 or something. And that might give you a slightly different answer. But yeah, it says 78 cents there. So, you know, just be careful with your rounding off, but pretty straightforward. That's all you got to do. Get some sleep and good luck. Cheers.